Okay, so we're going to finally finish up this section. We're going to do a couple of slant asymptote problems. So instead of having a horizontal asymptote, we have a slant asymptote. So with our guidelines here, the only thing that changes is 4, find and sketch the horizontal asymptote. So we'll go ahead and do the other parts first. So part 1A, part A is to find the y-intercept, and that is when you set x equal to 0. So you're taking the function evaluated at 0, which all these terms here are going to go to 0. So you just end up with negative 3 divided by negative 2, which is positive 3/2. So that's the y value. We haven't done this in the past, but you can show the y-intercept as a ordered pair. Okay, the second one is to find the zeros of the numerator, which are the x-intercepts. So if we can factor it, just using observation here. So we're going to say what two numbers multiplied together give us 3 and 1, and we need a negative sign in the middle one. So we have 3 and we have 1. One has to be positive, one has to be negative to get negative 3. So we put the negative with the 3 because that gives us a larger one. So then for this to be 0, this product to be 0, either one of the factors has to equal 0. So we get x equals 3 and x equals negative 1. So those are my x-intercepts. Then we set the denominator equal to 0, which in this case we don't have to factor because it's just a single term. So when the denominator equals 0, which happens when x equals 2, then we have a vertical asymptote at x equals 2. And then the final one is this instead of a horizontal asymptote, well, not the final one, we could plot at least one point between and one point beyond each x-intercept and vertical asymptote. So we can either use long division or synthetic division. So since we just have a single thing to divide here, we're dividing by x minus 2, so we use positive 2 because that's the 0 associated with this factor, and then the numerator is 1, not the numerator, but the coefficients for the numerator are 1, negative 2, negative 3. So bring the 1 down. 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. Negative 3. So what that says is that if we do this division, the function can be rewritten as so we have this remainder of 3. So we get x plus 0 minus 3 divided by x minus 2. So the remainder goes to 0 when x becomes very large, either positive or negative. So what we're left with is this is the equation for the slant asymptote. And remember, the slant asymptote is not x, it is the equation for the line that represents that slant asymptote. So this is the equation for the slant asymptote. So now what we'll do is we will get some graph paper. And let's see where the asymptotes are here. I mean let's do a little larger scale. So let's go positive 5, negative 5, positive 5, negative 5, and I'll just put tick marks here. I won't actually put the numbers in. That way won't get so busy. So each tick mark represents 1. Okay. So the first thing we do is we have the y-intercept, which is 3/2. So let's put that. That's 3/2 right there. We have two x-intercepts, 3 and negative 1. 1, 2, 3, negative 1. We have a vertical asymptote x equals 2, which is right here. So that's a line. And then we have this slant asymptote, which I'm going to try to decide whether I want to put a line. You know, it's going to look something like this, right through there, y equals x. And I think I can just leave it in there as a line. Okay. So the question is, what's going to happen here? So we kind of have a general idea of what's going to go on. You're going to come down here like this. Like that. And this one follows the slant asymptote. It has to be on this side because these data points are on that side. So something like that in general. So as far as point, we could pick f of 1 to get a point here. We could pick f of negative 3, so negative 3, 1, and let's say 4. So we're going to evaluate the function at 3 values of x. So we're going to do f of negative 3, I think that's what it said, f of 1, f of positive 3. And remember, the function is x squared minus 2x minus 3 divided by x minus 2. So we get negative 3 squared minus 2 times negative 3 minus 3 divided by negative 3 minus 2. And I'm just looking for my calculator. I think it's downstairs, so let me pause for just a second. Okay, so I get negative 2.4. Let's see if that makes sense. So we go negative 3, negative 1, 2, 2.4. So that's right there, so that's pretty close. Okay, then we need to do f of 1. So you get 1 squared minus 2 times 1 minus 3 divided by 1 minus 2. So that's going to be 1 minus 2, which is negative 1, negative 4 over negative 1, which is 4. So 1, 1, 2, 3, 4. So there we go, pretty good. And the last one here is f of 3. So we get 3 squared minus 2 times 3 minus 3 divided by 3 minus 2. So that's 9 minus 6 minus 3, which is 0, divided by 1, which is 0. Oh, yeah, obviously, because that's, so I should have done f of 4, not f of 3. I don't know why I did that. Four squared minus 2 times 4 minus 3 divided by 4 minus 2. So you get 16 minus 8, which is 8 minus 3, which is 5. 5 divided by 2, 5 halves. So we go over here, f of 4, 1, 2, 3, 4, it's 5 halves, 1, 2, 5 halves. So that one was a little bit off, not too much. Okay, so hopefully get the gist of that one. So there it is. This is a picture, but it's a little bit larger scale. Okay, we did that one already. Okay, let's do another one. Okay, so here we go. Same deal. A, set x equal to 0. You get y is equal to 8 thirds. 0, 8 thirds. That's your y-intercept. B is we see if we can factor the numerator to find if there are any zeros, which I think there are in this case. Except I don't think we're going to be able to just factor it, because you think of two numbers multiplied to give us 8, which is 4 and 2. 4 and 2 plus 4 plus 2 is 6. It's not equal to 5. So we need to use some other means. So we could use completing the square. So what we'll do is take that, move the 8 to the other side. You take 5 halves and square it. That's 25 fourths. So we add 25 fourths to both sides. So this becomes x plus 5 halves squared. And 8, that's going to be negative 32 fourths. We change this to fourths, plus 25 fourths. So we get x plus 5 halves squared. This becomes negative 7 fourths. So we get a problem. There are no x-intercepts because you can't take the square root of a negative number. And so it's no big deal, just the way it is. And then vertical asymptote is where the denominator equals 0, so you get x equals negative 3. And then finally the slant asymptote. So this time we'll use long division. Okay. What do we multiply x by to get x squared? X, so you get x times x squared is x times x squared. X times 3x, x times 3 is 3x. You subtract that. So this goes to 0. 5 minus 3 is 2, so you get 2x plus 8. Okay, what do we need to multiply x by to get 2x? The answer is 2. 2 times x is 2x. 2 times 3 is 6. Subtract those. This goes to 0. You end up with 2. So our original function is x plus 2 divided by x plus 2. So I get the x plus 2 from here, and then x will be divided by x plus 3. That was the original denominator, x plus 3. So I have a remainder of 2. That's the numerator, divided by x plus 3. So this slant asymptote is y equals x plus 2. So here you can see it. The scale that I'm using here is from -10 to +10. And there's only a y-intercept, which is here, y-axis, and it's 8/3. So this is 8/3 is a little more than 2, so there's 2. So it's 2 2/3. So that's right there. So you can see what's going to happen is this thing is going to come down like this. It's going to loop around somewhere. Don't know exactly where that is. Calculus would tell us exactly where and then it goes up like that. And then it has to go on the other, it has to go in this opposite kind of quadrant. So it's going to come down here somewhere and then turn around, kind of have some type of symmetry. And that's why you can see that there are no x-intercepts. So, you might evaluate the function at either like negative 1, 2, 3, 4, -4 for -5. You might evaluate it at -2 to figure out where that point is. I'm not sure if that's what I did here. Yeah, x of -4 and y of 2. So if you plug that in, -4, you get -4. So 1, 2, 3, 4, 1, 2, 3, 4. So that's that point. And if you evaluate at -2, you get -2, 2. So you get -2, 2, which is right here. So that thing does come down a little bit further. Got it down there and then loops back up. Kind of like that. Okay. And there you can see the picture again stretched out a little bit. Now this last one, I'm not going to put anything this difficult on a test, but the difference is, compared to the previous ones, is that this is cubed and this is to the first power. So the asymptote is not actually a slant, it's a polynomial. So I just wanted to show you how that would work. So again, you're going to either use long division or synthetic division. So I'm going to use synthetic division. So we're going to use x minus, we're going to use -3 here. These are the coefficients. Make sure that we have one for each term, which we do. There are no zeros here. So take 1 down, -3 times 1 is -3. Add these together, you get -11. -3 times -11 is +33. Add those together, you get 44. -3 times 44 is going to be -132. How did I know that? Well, 3 times 4 is 12, so that's 120. 3 times 4 is 12. So 120 plus 12 is 132. Okay, add those together, you get -112. Okay, so what you're left with is x minus 11x plus 44 minus 112 over x plus 3. So that's just a different way of looking at the function. So in this case, forget the squared, this is the asymptote. So the asymptote is a polynomial, a quadratic instead of a linear function. And this is, what does this asymptotic function look like? Well, we could plot it. You could use, I'm not sure if you can factor that, but you could put it in standard form if you wanted to. So the asymptote looks like this. So this function, x squared minus 11x plus 44, looks like the blue curve. And so you can also see the vertical asymptote at x equals -3. We have y-intercept and 3 x-intercepts. We get those by finding we've got three roots of the polynomial in the numerator. So it looks like those are maybe at -1, 4, and 5, something like that. So you plot the x and y intercepts. You could plot this, estimate this quadratic, and you can see as x gets larger in this positive direction that the red curve and the blue curve approach each other, and the same way over here. The red curve approaches the blue curve. And if you zoom out even further, you can see how the asymptote works. So it's, like I said, it's not a slant. It's a curved asymptote, but it does approach the result of taking the original rational function and rewriting it as a polynomial plus this kind of remainder term. Okay, and there's the homework assignment.